Okay, and we're back and live to the second session of the day. And I'm happy to have here with me Victor. Hi, Victor. How's it going?
Hi, perfect. Looking forward.
Yeah, you look very excited. And we're also excited to have you here. So I know that you're going to talk us a little bit about refactoring, right? I'm really excited about that topic because I think it's like a general topic and I think it's really useful for a lot of developers.
Yep. It's something that we must do every day.
Yeah, and even I also always joke with my wife that I'm gonna be refactoring like the kitchen or like the bedroom.
The food is very good.
Okay, so Victor, I know that you have a very awesome session for us. So I don't want you to steal you any time. So please, the stage is yours, and I'll try to relay back any questions that we have back. So feel free to go.
Yeah, so again, folks, if you're watching, please feel free to ask at any moment. I'll do my best to answer as soon as I see the questions. So let me share the screen. I think you should be seeing them. Let me open the chat to be in sync, and I'm done. Good.
Yep.
So refactoring, blockers and codes. Let's do this. This is my favorite topic. Talking about refactoring is clearly my favorite topic. So first, let me introduce myself. My name is Vitor. I'm a Java champion. I founded a community, which is called Bucharest Software Craftsmanship Community, that I invite you all to join. I'm doing free stuff every month in there. It's one of the largest communities in Romania today, of developer communities. I have a website on which I have a series of my best talks recorded from previous conferences, a little blog, and some video courses available over there. Because what I'm doing for a living today is training. After 14 years of development and 7 project led, I am currently just doing workshops in different companies, super intense workshops. Not as intense as this talk, but super intense. So string, hibernate, functional programming, Java performance, reactive programming. All of these things are in my agenda. Design patterns, pragmatic domain-driven design. Look how good this one reads. Clean code, refactoring, unit testing, test-driven development, and yeah. If you're interested in any of these, you can find more details on my website. I also have some workshops recorded available on the Teachable platform if you're interested. You can find me on the social media also. Twitter is the best, of course. So this is how you can reach me later. Perfect. I will post the slides of this presentation afterwards. There are links inside, so you might want to navigate through them. So this is code. Yes, this is code. This is our kitchen. This is code. And we need to refactor. We need to refactor that code because otherwise we are dead. Otherwise we will die. Otherwise we won't be able to deliver stuff. Otherwise, our life will be miserable. So we need to refactor to clean continuously the code base. But what the heck is refactoring? To start with the definition, refactoring means to simplify the existing code. And when I say simplify, I mean simplify as for the eyes of another developer. Clean code is all about caring for the others in the team. So simplify, make it more readable, more maintainable, but without changing the current behavior, the current observed behavior. In other words, do not break production. Thank you. I will play this again. Do not break production when you refactor, because otherwise you will lose the trust of your managers, of your tech leads, and they will actually stop you from refactoring. So they will stop you from taking out the garbage from your kitchen. You don't want that. Right, so fear, this is the first stopper. You can already feel it, okay? We are afraid to break things. And then a typical discussion in a project, I'm afraid to refactor because we don't have tests. Oh my God. So what your lead will tell you, what your colleague will tell you, well, write tests, right? But then you will come back and say, I can't really write tests because that method has 200 lines. How can I unit test a 200 lines method, right? And this is a famous vicious circle of legacy code. Of course, you can't ask you can't ask an artificial intelligence tool to generate you tests for the existing code reliably. So actually, the only reasonable way to break this vicious circle is by doing safe refactoring, by making sure you don't break stuff, even if you are not having enough tests. So I'm talking about terrible legacy over here, okay? If you do have tests, so you're very fortunate, you are in those 10% most fortunate developers on the planet, but most of us, we don't have tests on the horrible legacy code that we have. So pair programming is one way to reduce bugs, okay? Proven. coding katas, practicing, to make sure that to practice the moves and to learn them and to master them as to not to introduce bugs when you're doing it. Practicing TDD, folks, I'm not saying here that you should TDD on 100%. I'm saying that practicing TDD on whatever problem, ideally from production, anywhere in production, practicing TDD will increase, will skyrocket your skill level. You will know where you do bugs. You will know where the problems are. When you will know how to decouple stuff. So practicing TDD in itself will grow you enormously as an engineer. And I've seen this. I'm working with people basically all my time. So I've seen the difference after people started practicing test-driven development. Right now, there are some tips from me also how not to break production when you refactor. First of all, do not ever break compilation. Okay, unless you are deliberately exploring stuff. So I know very good developer that breaks production tentatively to see where it breaks. I mean, just for fun, just to see where the impact is, and then revert and start over, right? But that's exploring. So don't break compilation, because if you break compilation, your IDE will not be able to refactor safely anymore. The refactorings that are otherwise safe, like extract method, like rename a variable or rename a field, they will break if the compilation is not successful, right? The abstract syntax tree will not be constructed correctly, and basically your editor will fail to find references to your tokens. Then also having broken compilation increases your stress level, and you don't think clearly if you know that you have 73 more compilation problems to fix. So do not break compilation, okay? How can you not break compilation? Is typically by decomposing larger changes into a sequence of super tiny safe steps, okay? And you have to learn those safe steps first. These are the refactoring, the automatic refactoring is available in your IntelliJ or your Eclipse probably. And then you will have to work out ways to chain those simple steps into larger, to achieve larger changes, all without breaking compilation, or at least breaking it for the least amount of time possible, like several minutes, right? Use quick fix, alt-enter driven development, I call it, right? I also have a poem for that. I wrote a poem when it's red, yellow, blue, or gray, alt-enter will save your day, right? And these are, to be politically correct, these are the alternatives. But the idea is to use quick fix as much as possible, because that will allow you to keep your focus on the design and take off your mind the nasty thing of writing and making things work correctly. I mean, code stuff like editing code. Now, of course, this was fear, okay? The next thing, actually, the first thing most teams tell me when you want to ask them what stops you from refactoring, most teams tell me time. I don't have time. I don't have time. But you know, we will talk about two things. First of all, the allocated amount of time to do stuff, and then your speed. And well, let's focus first on speed. I don't have time. I'm too busy. That could be a trap. That could be a misconception. You could be biased. You might think you don't have time. Actually, to be perfectly honest, whenever you think that, that's actually a form of laziness. Being busy is a form of laziness. Well, what do you mean? I mean, being busy, the state of being busy, it means you don't take time to stop and reflect what the heck you're doing. So being busy is a form of laziness of using higher level thinking, of critical thinking, and see, what am I doing? Am I doing the right thing? Does that really matter? Right? And I would really invite you to watch this video on YouTube. Then improve your focus. Okay, that's super important, because you know most developers, after several hours of coding, maybe at the end of the day, they have this face like, huh? What did you do? I programmed for 6 hours. So your brain dies at some point, right? So super important for our profession is to maintain your focus. Super important. And here are some tricks, right? First of all, disable notifications in your mobile or desktop. Don't have things buzzing in your pocket or on your table, right? You want to keep focus, keep there, right, in the problem, right? Automate stuff, right? That's why we love unit tests, because we can start them in the background. They will run, actually automated tests in general. Start them in the background, and after you just fire them, you just come back to the problem and keep your focus on that. To remain in the zone. Keep your attention to the problem, right? Pomodoro. It might work for you. 25 minutes to do stuff. 5 minutes, relax, look at the window, answer emails, relax, yeah, walk away a bit. Fragmenting your time frame to be able to better focus in those 25 minutes. Avoid checking your inbox in the morning. What? Why? Because the morning is the moment in time in which your brain is at its best. All right. In the morning, your brain is fresh, is full of energy, it wants to do stuff. And what you do, you're checking inbox. You are giving away the best of your time to someone who wants something to be solved. Don't. Dedicate your inboxes, dedicate your mornings to solving the most critical task at hand. Okay? Shorter meetings. No one focuses after 30 minutes. So after 30 minutes, just silently leave. No, just silently do the dishes. Oh no, silently propose to end the meeting with a meeting minutes, maybe. Right? Digital detox. This works for me. As you can imagine, doing workshops every day, it can be exhausting and prone to burnout. So what I'm doing basically from Saturday to Sunday, I avoid touching my phone. What? I do not touch my phone. I avoid touching my phone unless emergency. It's super important to relax and to get bored. Again, I will point you to this wonderful talk. It's a TED talk, how you can improve the focus of your brain. Master your IDE, of course. If you are concerned of putting a semicolon at the end of the row and doing backspace, then you're lost it. Then you can't really focus on the real problem. You are in the writing mode. What are you doing? You are a typist or what? You are those guys in courts that they write whatever gets spoken, right? In lawsuits, for example. Yeah? Those guys. Are you that guy? No. You want to think. You want to see the big image, right? And here's a link to one of my talks with some lead developers from JetBrains themselves who were with me in a talk this spring. At JPoint, talking about intelligent productivity tips, showing how the hell do I write code like I do, because yeah, I'm pretty fast. Good. So that's about speed. Now, time frame. What does that mean? It means basically how much time are you allocated, or can you invest in that refactoring? And this clearly relates to estimates. How do you estimate? Now, I don't want to convert this discussion into a talk about estimates and function points and other stuff. No, that you know that better than me perhaps. But the idea here is that those estimates that you shoot are wild guesses, basically, most of the time. And it gets worse because you really are emotionally involved with the project. So you really care for the project, right? And you're still throwing knives at it, blindfolded. Right, and it gets even worse because the requirements change every time, right? So this is you basically throwing estimates at your beloved project. Right? Now, keep this picture in mind. This is what you're estimating. So make sure you do your best and maybe do a little prototype before you actually estimate. Right? Estimate the estimations, right? I found some things doing that. In case the problem is very hard, they will estimate the effort to estimate. Right? Why not? Why not? And if there's one thing I want to point out, I will stick with Uncle Bob on this. I will say, learn to say no. Learn to say no whenever the business pushes you to run for more than several sprints. You can run for a sprint. Okay, yeah, life is life. But after that, you need some time to regroup and to clean your shit and to clean your code. So learn to say no, learn to estimate. Man. Now, of course, there are these classical risks that you can encounter when you are estimating. One of the risks is to have a technical challenge, very, very creepy thing, a new technology, like the first time you're using Kafka, for example, right? So you want to have a little prototype, perhaps, before you actually jump into the code, to experiment a bit. I mean, let me first try out something before, and after that, I will estimate the effort. In case the functional complexity is very large, of course, that's the point of Agile. You should iterate. The minimum viable product is your friend in that case, right? And if you're here, don't. Yeah. This should solve the time and fear. That's it. I solved it. So now you have time and you don't fear the code because you know how to do safe moves. Please note this sign. Okay. What are the things stop us? And actually, I'd like you to think honestly. Did it ever happen to you that while you refactor something, you found out another thing to do. You discovered another refactoring that you could do while you were already in the middle of changing something. Okay, this happens extremely often. Okay, that's why refactoring is addictive, really. Because when you refactor the code, you learn the code. I would actually claim that there is no better way to understand to understand some code than to try to refactor it. If you put your hands in that code, suddenly it becomes way clearer what goes on inside. And that's why you find out more ideas about what you can do next, right? And then you know what happens really? You keep falling from one refactoring to another, okay? And then you want to stop it. You want to get out of there, but you can't, okay? Because you got carried away. You got carried away. And after 3 hours, you get to commit. You get to commit. After 3 hours of insane cascading refactoring, you are about to commit. And what commit message would you put? Code improvement. Refactoring. It's late. Major changes. I love this one the most. Boo! Major changes. Like boo! Right? This is the thing that you put in the commit messages after 3 hours of insane refactoring without really looking what you're doing, just randomly changing code. And this is bad. Imagine how someone would refactor this. Would review this. I mean, just imagine looking at the pull request, right? So here's a challenge for you. I would challenge you to write down your next commit message on a piece of paper before you start coding. You grab a pen. Remember those pens? You grab a pencil or a pen, and you write on a piece of paper what you're about to do. Like, what the heck? How could I know? Right? In most cases, you don't really know what you need to do. So you first need to explore a bit. You first need to run a bit around and to see what's there. And that you can do with a time-boxed exploratory refactoring. Like 15 minutes, 30 minutes. I've done that extremely frequent whenever I faced a complex problem, because there is no better way to learn code than by actually trying to put your hands inside. So of course, after those 15, 30 minutes, you revert. Okay? Honestly, I think that this practice is currently missing from our habits. We should be doing this more often. We should be, whenever we don't really know how to estimate something or we don't know what we need to change, we should be in the habit of, okay, committing everything that we had until there, and then explore a bit the landscape, see what's there, then revert and come again doing super tiny commits every time, okay? Now, so you have a big problem to solve, a big refactoring to do. You identify the steps and then you do the changes, but the changes that you do on a branch that lives for 2 weeks, for example, or 3 weeks. Imagine a feature branch that lives a month, a feature branch that lives a month. And suppose you are fortunate and you get to work in pair programming. Now, in those 4 weeks of work, you will have ideas how to improve the code. You will have ideas. You will say, well, I want to change that. So that's bad. Let's change it. And that idea, you will refrain because you know what will happen if you do the refactoring. I mean, a larger scale refactoring. Then the merge conflict will happen. And this is one of the most annoying things in the life of a developer, next to interruptions, refactoring tests, and endless meetings. This is what annoys us, one of the in top 5 annoying things to resolve merge conflicts. Okay, so what happens really in practice is that you will not refactor because you know the pain that you will go through later. What are the, let's say, workarounds for that? But one brutal workaround is to go for trunk-based development. These are links in there. You can click on that in the PDF. I will share the links after the slides on my social channels after this conference. Trunk-based development really means that you are working on the single branch and you write your stuff which is not yet done under an if. This is a bit scary for most, especially for most tech leads. What do you mean? And then what? And then I ship to production with a feature which is not ready? What the heck is that? Okay? This will allow you not to fork, not to branch. Okay, but you do need a very mature team. Okay, and very disciplined team, probably pair programming, TDDing, incremental DB scripts. It does come with continuous deployment pipeline. It does come with some more, let's say, high-end practices, if I can say that. That's why most teams don't really approach this. So a workaround, an easier workaround, is whenever you are facing a larger refactoring, to maybe just drop what you're doing, come back again from master, do another pull request in which you do the preliminary refactoring, submit that separately to code review, merge that new branch into your branch, okay? How to draw this? Merge this into this and continue from there. So do not do massive refactorings on your branch, of course, because yeah, that will kill the merge later. All right. I think I threw many ideas already, but here's one more. It's not my idea, this one. It's from JBrains, from Rentea. It's called Microcommits, but it works. It works like a charm. It goes like this. Whenever you are about to commit whenever you are working on a feature, do not squash, or do not commit one single big commit, okay? But do multiple commits, and don't squash them when you submit the pull request. Allow your reviewer to walk through them, and then in those commits, you should make separate commits. Whenever, for example, you do a large scale but safe refactoring with your IntelliJ, for example, imagine you're renaming a package. That will change maybe hundreds of classes, but in a very superficial and safe way, right? On the other hand, you might be trying to do sometimes some refactoring, but without using the tool, without using IntelliJ, without using any automatic tools, like messing with booleans and doing like brain stuff. No matter how much I insist not to do that, but to use automatic tools, you will do it at some point. Whenever you do it, commit it separately and draw the attention of the reviewer, and that here bugs may be, right? There are very few bugs in here, although there are many changes. So, but it requires discipline, okay? And the third thing, of course, is when you add behavior. So the point is to commit separately to allow the reviewer to maybe even at some point skip these commits. Skip this, maybe. In IntelliJ, for example, when you look at the Git history, if you control-click several of these, you get the merged diff here in the right part. So you can actually skip those that are safe in some extent, but you do have to trust the team that you really just did automatic refactoring in there, right? Because otherwise, your reviewer will just look at those refactorings without really understanding what happens, right? So this will lead to easier code reviews and less bugs. That's interesting, because if you are able to do that, it means that you are really understood the problem and you really identified the steps. And if you identify the steps to do in the refactoring exercise, then 80% of the problem is done, okay? So by aiming for this, you actually get to a stage in which the direction that you go is clearly the good one, less bugs because you do super tiny commits and each one can be checked individually. The problem is indeed that you need to explore, you need to know the steps, you need to know what are the refactoring steps. And I had some experiences of that in my life. We reverted the work we did in pair programming. We reverted the work we did the entire day. So at 6 p.m., we reverted what we did the entire day because we couldn't just close it. We couldn't just come back to compilation and passing tests. The next morning, we start over, but it was far easier, infinitely easier to do 50 commits that day, all right? Good, so recap, what stops refactoring? First of all, time. In this regard, make sure you do sharp estimates as precise as possible and honest as possible. Learn to say no, improve your focus. I also found some teams, some people, which were rushing, although no one ever put pressure on them. I mean, they were in this habit of, oh, I need to finish fast. My friend, do your best, right? And even if I told them, do your best, they would come back to me, I'm done. But I knew they couldn't have been. So, and I asked them, is it really, really good? Is this the best code you can ever write? They always left to do one more improvement. So don't rush unless you really are under pressure, right? Fear, okay? Tests would fix that, of course, but pair programming and practice will also fix. I mean, would also alleviate, lower the risk of that. Merge conflicts, okay? Trunk-based or short-lived branches. Lack of skills, but then that's the focus of the next part of this presentation, learn code smells. Another thing that happens is that you might not know the code. Imagine you are in a new project, you join a new project, and you have some nice ideas to refactor, but you don't really know the functionality of the code. If that's the case, remember, there is no other better way than learning the code than actually trying to refactor it. That's a trap over here. And I also fell in that trap, in this trap very, very often. I didn't know the code and I was afraid to touch it. But it turned out that if I really would dare to just throw myself in for 5 minutes or 10 minutes or half an hour, I already got a much better image while trying to do some little changes in the code. Right? Then just yesterday, I had a team in which one of the brightest guys told me, okay, but if I see a huge pull request heading towards me, I will ask, why are there so many changes, right? So to make the life easier for your reviewer, do microcommits, and also you should be able to trust your colleagues. That's a tricky one in large teams. Lack of consensus. You don't really know what's good for the team. You don't have a, let's say, shared understanding, or you don't have those design goals set for the team. And I will advise you do some regular team design brainstorm meetings. Just 1 hour. What do we try to change? Not today, tomorrow, in 1 year, in 1 month. What is the goal? What class annoys us most? Which one do you want to break, and so on? It's super important for those which are new to the team, or those that have energy but don't know exactly in which direction to pull. Right? Fear of breaking some eggs to make the omelet. That's deep. It means that's deep. You have to break some eggs to make an omelet. What do I mean here? I mean that in time, the code quality always goes down. Okay, that's the universal law of thermodynamics. That's actually the second law of thermodynamics. The entropy in the universe tends towards infinitum. The point is that you will be here at some point facing a large evolution that you see clearly that it will crash your design. You know for sure that if you don't do anything, your quality will just go very, 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 very bad. So what do you do? I'm talking here about the complex refactoring, the more complex refactoring. What do? You say to yourself, let's make refactor. But the reality is that most of the time, the first step to do is to merge code together and to get to worse code. That's counterintuitive. I should be cleaning, right? But the first thing you do, for example, you might merge two methods together in one single huge method to see the big picture and then break it up again into much smaller methods. So very often I did that in large legacy code bases. First thing you do, it feels like you're doing more mess than cleaning up. And that's true. That's really what happens. Because the deepest refactoring starts with making a bigger mess. There's a theory underlying that, but it is a local minimum of entropy. So you now shake the system a bit, and then it arranges in a different style, in a different structure. Complicated. But the idea is, however, that you have to have faith that you will reach the other end, right? And also not only the faith that you will reach that other side, but also the strength to revert. If you see that you never recover, if you see that the road is blocking and it's going to nowhere, you should be able to revert without crying, right? And that helping with that is being fast. If you are fast, you won't be very depressed if you throw away 1 hour of work. If you are quite slow and you spend half a day or a day doing that, of course you'll cry. Okay, it's very depressing to throw out your attempt. That's what I mean here by fear of breaking eggs to make breaking eggs to make the omelet, right? And of course, I need to mention this. The YOLO-driven development. Do you know what the YOLO-driven methodology is? It's quite beautiful. Let me share with you. Do not refactor. It is a bad practice. Do not read documentation. Do not use naming conventions. You only live once. Don't indent. I like the last ones. I don't always test my code, but when I do it in production. Right. Perfect. Real men deploy to FTP. Like, I want to be a woman, man. So do not use naming. This kind of guy that just, I don't care. Right? If you are facing such a colleague, it's very hard to, it can be really, really challenging to get him on the right track. The first thing I will try with such a developer, I hope you never have to work with such a guy, but first thing you do, you make it fun. You play together. You solve some refactoring coding cutups. You do some pair programming sessions. You do some interactive code reviews with him, and you discuss and debate and share with him the joy of writing code, because writing code is fun. Refactoring is fun, it's addictive, it's super interesting, right? Share that joy with him. And if not, there is also the legacy experience. That COBOL project that is 25 years old, that has a bug that someone has to fix. Let's not go there. Good, so that's basically what stops us from refactoring, okay? Time, fear, lack of skills or knowledge about the project, consensus with the team, chaotic refactoring, merge conflicts, risks sometimes to do a bigger mess, and careless. I don't care. Good. Now let's focus about code smells. That was the second part of the presentation. Yeah, it's only 15 minutes. I could speak about that for one day or two, but really scratching the worst code smells out there. I will start with the king, which is large method. I've seen methods of more than 1,000 lines. Yes, 1,000, 1000, 10 to the power of 3. Yes. I've seen classes of 35,000 lines of code. 35,000 lines of code. Let me write this down. Perhaps you don't. You may be the happy developers in Java that work with small little microservices, but you have to know that the vast majority of the current code base in Java looks like, maybe not like that, but yeah, worse than your code. So a method larger than 20 lines should be, of course, broken down. 20 lines fits a screen. It's the old rule from the time of Borland C. But you can actually make it shorter if that method contains creepy, weird business logic. If your head hurts when you read the method, even if it's 20 lines, break it further into smaller pieces. And of course, there are other how do you call this? Other factors that will push it to refactor, like to break functions, like separation by layers of abstraction, like model view controller to split presentation from business logic. There are many reasons to break a method. So speaking about the number of lines is superficial in reality. But yeah, 20 is like a maximum, maybe even 30 for stupid methods. But for those methods which takes time to understand, make them shorter. But of course, there is a reverse to this method. There is a downside. I mean, you shouldn't really. I mean, if you can't find a good name for a method, don't extract the method and name it F1. That's not the point. The point is to extract the method so that it tells a story. If you don't have a good name for the method, maybe even better, leave the bigger method in place. Maybe sometimes. Goat class, of course. Now for goat classes, there is no excuse. For large methods, yeah, you could sometime go over that, but 200, 300 lines maximum, after which the build should fail. The build should have a build plugin, a Maven plugin that fails the build if you commit over 300 lines, to be more generous, let's say. Okay? So goat class are extremely bad because they clearly violate both of them. They violate the single responsibility principle. What are you doing in that class? Right? Does it have a role, or is it just a bag of functions? Now, too many parameters. This is one of my favorite. When I do the Clean Code workshops with different teams from various companies, if I have 2 days with them, I ask for production samples and I refactor those production samples in front of them. And very often I find methods with 7 arguments. And I think more than 30% of the time, I can find a class that would group those parameters. Let me quickly show you. I want to demonstrate a bit of code also. So you have this intervals intersect, for example, with 4 arguments. I know it's silly. It's a silly example, but still. And the idea is that you have intervals intersect start of the first interval, start of the second interval. There are 2 intervals in here. So you might figure out that you are missing a class that you might group together these 2 arguments. And you could, of course, go Tarzan style and say, I want just to do interval. But if you do that, your whole compilation will break, right? I mean, it's frustrating. Your cortisol level rises, your lifespan decreases. You don't want to do compilation failures. So there are a couple of solutions. The most geek of them is the following. You just introduce a parameter object. creating a new class called interval. And you say to IntelliJ that I want to put these two inside. And this creates a new class, for Christ's sake. And everyone who ever called this method now get to instantiate the new class. And it's like, what the heck, really? In a second, right? Boom, there's your interval. With a bit of polishing, it's done, really. Start, end, right? Come on, it's obvious what I'm trying to do. So here, end. Good. So interval, start, end. Very nice. Now, I want to use the same interval into here, right? So the same thing. Introduce, please note the shortcuts that I'm spacing. Introduce parameter object, introduce parameter object. I have a cheat sheet with all the shortcuts, with most shortcuts that I press on my website. Clean code interval, there you go. And start end too will be using the same class that I created previously. Refactor, boom. And when I do that, the code changes everywhere with no breaking changes, no compilation failures. That's what I want to say. Right. So this is interval 1. And this is interval, not the right press. So Control Z, I just pressed the most useful refactoring in the world, Control Z. Right? Just I did it wrong. I did a collision. So interval 1, there you go. And then you realize that, wait a second, since I have this interval class, why not putting this bit of logic, this bit of homeless logic into the interval itself? So I can do this with F6 or not F6, actually it's called convert to instance method, in which IntelliJ asks which class will become the home of this method. And you say the interval. It's quite mind-blowing. How does it do that? Right? Boom. And there you go. You are in the interval. This is your method. Of course, the name is not correct. It's called just intersects. Perhaps it's better. And this is just other. I won't call my own getters also. It's like start. And this end, of course, I don't call my own getters here also. It's done, right? And this is it. In the other place, the code was automatically updated. This is just an example of some things you can do with IntelliJ. Eclipse doesn't know all the steps, really. But that will do the stuff very easy, right? And what we actually did, in the new class we discovered, we've added some logic. Well, that's quite interesting. That's OOP over here. Right? You can get to dissipate your logic into the objects that you're working with. Super powerful because it cleans away the middle part. The high-level policy becomes cleaner if you push the nasty little details in the collaborator objects, like I did over here. So this is very, very deep, really. You just find some grouping of data that moves along without a name, and you make it, you give it a name. You make it interval, for example. And very often you can detect this by looking at the methods with a lot of arguments, right? Very often there is a little object sitting in there while waiting for you to discover it, right? And then what you do next with that little object that you discover, you can actually push it. You can actually simplify your code. You can enforce constraints on this interval. Does it make sense to construct an interval if the start is after end? I guess not. So if, throw exception, done, right? You can enforce constraints, you can add logic, and you can reuse this object into other larger objects by composition to basically simplify your entities, simplify your data objects throughout your entire system. So this is a super powerful idea I think is the most common thing I note in projects that I see. The fear of creating new classes. People just reluctant to creating new classes, right? I see it all the time. Of course, the classes that you create should not just be dumb with get and set, but instead they should have some bits of logic inside, right? Like I did with this interval. And as a matter of fact, remember the method from which I came? Let me just try to use this technique, right-click, git history for selection, for example, yeah. The method from which I started was using two intervals at some point. When I used two intervals, this method was suffering from a code spell known as feature envy. One of my favorites. When there is logic which operates on state of another object. What you can do, what I see people not doing on a common basis, is to push that logic next to the state, right? most of Java developers are in this mindset that we have to have logic in the services and entities in some their own dynamic model. No, I want you to enrich a bit the model, to disseminate the logic that you can work on the state of a single object, to put that method in that object also. Primitive obsession takes this even further. Talks about us using primitives everywhere, like this one. Redeem coupon, long string. If you just look at the types, nothing tells you what is this long or what is this other one. And you might actually confuse them at some point. You might pass the arguments. You might swap the arguments by mistake at some point. Or this one. Oh my God. Map of a long to list of longs. What the heck is that, right? This long over here is not really, only by looking at the name of the variable could you figure out what these are. This is called primitive obsession, and one solution to that is to define microtypes. This is what they call it. For example, customer ID, coupon ID, phone number, super tiny objects that represent this long. And you can't possibly confuse one with the other because they have different types, right? Or here, this is really cool. Map of customer ID to list of order ID. But folks, don't get me, I want to make it clear. This object hides inside a single long. It's like a wrapper for the long to provide semantics. Okay? This is very cool. You might be tempted to do it, but my warning for you is that this is a decision to take at the beginning of a project. This is not possible to refactor to such a convention after 1 or 2 years of development. You will not be able to pull it off. It's too hard. Right? So primitive obsession, to escape the primitive obsession, you made the concept explicit by introducing new small classes, even if it's a single string or a long. Right? The ID type is called in domain-driven design. It's quite a technique to look into. Right? Then, one more dramatic code smell. Between these two pictures, there are 5 differences. I'll let you several seconds to search for some. 5 differences. Well, there is the bush, of course, but there are 4 others. Right? Now, why am I showing this? Why? Because this is you comparing 2 pieces of code which are almost identical. But you will find several minor differences, and you will ask yourself the $1 billion question: is it a bug or a feature? Is this bush missing for a reason, or is it just someone that changed this code but forgot to cut the bush from the other part? Okay. So this is what happens to you if you copy-paste code, if you duplicate code, of course. You knew that, but this is when it gets really nasty, right? Duplicated code. Another symptom of that is when you get to change a lot of classes, when you do like trivial changes, result in changing 7 classes at once. Right? This is called shotgun surgery. Right? The idea is to unify the identical code, of course, by extracting methods, classes, unifying stuff, putting them in the same place. Right? The opposite of that is not doing that. Unfortunately, I don't have time to explain what this would mean, but the general idea is that a function is called by many parties, by many places in the code, and this method grows to fulfill the requirements, the needs of all its users, of all its callers. What will end up, it's a huge method. In this case, what you should be doing is actually to split the method into subparts, generally speaking. So divergent changes is the act of refusing to copy-paste anything and to reusing a method for a very large number of cases. And I want to throw some more ideas at you here. First, switch. Switches are a code smell, right? Not any switch, repeated switches, right? And when you have the switch on the same thing placed in several parts in the code, if you add in one part one extra case, the risk is that you will forget to add the matching case for the other switches in your system. So this is why repeated switches are bad. Now, one classical solution for that is to employ polymorphism. But there are other alternatives, more concise, like enum with logic or function references. And of course, the most awaited functional switch in Java 17, which is very, very good, and it could actually could actually catch cases in which you forget to add cases. I don't have time to demonstrate that, but you should think about repeated switches and do something about them. Loops in Refactoring second edition, the book in December 2018 by Martin Farrer and Kedbeck, one of the key or one of the cornerstones of refactoring, says that loops are a code smell. Like, what? Loops? A for is a code smell? The reason they mention loops there is that today, with the tools we have in most languages, Java including, having a for doing multiple things is dangerous. Especially since the alternative, I mean, what do they say? If a for is large and doing many things, we should break the for into multiple fors, like for and for, 2 fors. And then maybe later move to a functional style code to just do the A separately, do the B separately. There are some catches, some tricks in that regard, but loops should be avoided today. Let me see, how much do I have to? Oh, just this is the last thought. Yeah. So imagine a function do stuff, and you find out after several hours of minutes of inspecting the code that before calling do stuff, you have to set x, because the method do stuff reads from the x field. So what you do, you need to put set x before. And then you find out that that function produces some outputs which it leaves in a y field, in the y field. So you need to get the results of that function from this field. Oh my God, this is so bad. This is called a temporary field. X is a temporary field holding some data in the object until the do stuff is invoked. What you should do instead, of course, is to pass the argument in as to the function and get the result out from that function. Okay, this is called temporary field, but it also is a sign of temporal coupling. You can mention this as being temporal coupling, because if you swap the order of these 2 lines, your code will go, yeah, we have a bug, a not obvious bug. Right? Temporal coupling. The order in which we invoke methods starts to matter. Extremely evil in large code bases. Okay. So avoid temporal coupling, avoid temporary field, and also avoid mutable data, especially if it lives for a long time. I also had some talks about immutability and pure functions, so go Google. But the idea is that mutable data, if it lives, if 1,000 lines of code have access to one mutable instance, one of those 1,000 lines of code will attempt to change that object, will mutate, will call a setter. And this is bad, because it becomes then extremely hard to find out who changed it. Extremely hard. That's why we go for immutability for the more complex parts of your code base. Now, of course, if you put multi-threading to the party, then rest in peace, my friend, because multi-threading plus mutable data, global, this is the end. And actually, this is the end. Why does it matter to know code smells? Because defeating the evil starts with naming it. Why? What do you mean? Our brain operates with words. I ask people, look at this code. Do you like it? And they say, bad code. And then I continue. What is that you don't like it? And they say, I don't know. It just sucks, right? This is normal at the beginning of your career. But the problem is that if you don't have words to name what's wrong with the code, first of all, you don't know how to fix it. Secondly, because all the code smells, by the way, in this book, in this wonderful book, Refactoring second edition, chapter 3, it's how I would advise you start reading. It's called Bad Smells in Code, lists all the major code smells out there. And in every chapter, there are links to how you can fix those. Links on how you can fix those. Like with refactorings, there are mechanisms how to fix every code smell in the world. Right? So you need to know code smells first, because you need to know that there are solutions to that. And second, because your brain needs to operate with that. So you need to know about long method goat class, data clumps, long parameter list, primitive obsession, feature envy, especially this one. Data class are bad. Duplicated code, shotgun surgery, divergent code, like we explained, repeated switches, loops, temporary fields, comments, right? You need to have, and there are much more in this book, and also on some websites out there that you can read. Very, very, and something that you really have to know. This is the end, or is it? Is it the end? Is it the end? No, it's a beginning. Because there is much more to study. There is the first half of this wonderful book, Clean Code, from Uncle Bob. There is the chapter 3 that I quickly skipped through. Chapter 3 from this book, and then read following the links. This, in case you're completely newbie for Clean Code. And this, if you want to practice with your colleagues in some workshops, in some mob programming and stuff. That was Abadi, that was all, folks. Thanks a lot and I hope I didn't speak too fast. It's all recorded, that's the good news. If you want to reach me and join my community, this is my site, this is my Twitter. Yeah, you can find me. Thanks a lot. And I'm on time, incredible.
Yes, you're on time. I mean, thank you so much. I mean, I think it was like an awesome session. The feedback that we're having over here, over YouTube and our social media is actually positive. So some people are actually saying that you have too much coffee, maybe because you were very excited.
I didn't drink coffee, especially to be more relaxed.
Yeah, but I mean, you were so excited, right? So people really love your enthusiasm. So I mean, thank you so much for bringing that. I mean, it's really awesome to see it here so much in the morning, at least for us. I mean, I know you're like 2 hours away, I believe, from us.
It's 2 o'clock.
Yeah, so in here it's like 12. Yeah, I mean, I don't think we have just like these couple of comments. I don't think we have any more questions. Anyway, we don't have too much time left. So
Twitter.
Yeah, I mean, you have a Twitter, so you can please reach out Victor on Twitter and ask him things directly. I'm pretty sure he will more than happy to answer them. He's very active on Twitter. So yes, Victor, I'm gonna let you go. So thank you so much for joining us today, and hope we will see each other again anytime soon in person.
God, we hope.
Yeah. Bye-bye.
Thank you. Take care. Bye.